tests related to rational functions. As you can see here, this is an old version of test that is going to be adjusted. And we're going to use this as our practice test because it includes all the problems that are going to be present in your test, okay? So today we're going to go through each question together. You can ask me questions if you're not sure about which answer to pick. Please take a moment to allocate your writing accessories and we're going to start. Meanwhile, if anybody has questions regarding past material, you can text in the chat. Okay. So right now we're going to practice unit tests. Okay, good job, Sam. So we're going to practice the Unit 3 test. In today's class, we're going to go through the questions that are involved in this test. And I'm going to solve them with you together so you have an idea for your final test on Wednesday. I'm going to give you different questions. So starting with question number 1. Multiple choice question would be the first part of your test. As you can see, grades are divided into knowledge, application, etc. I believe on your final test is going to be a few more of those. This one is part knowledge and understanding. Multiple choice part, you have 4 choices to pick. Question is, which of the following is the reciprocal of a linear function. So we remember the linear function is supposed to have the degree 1, right? X to the power 1. Using that, we can cross out b right away. It won't suit us because it's x squared. Secondly, for linear function, we should remember that numerator supposed to be a digit, not a variable. If you see variable in the numerator, it's gonna be it won't be a linear dependency, because if you take a reciprocal of this, you're gonna see that x plus 1 divided by x, which in result gives you 1 plus 1 over x, which is not a linear dependence. Okay? So in this question, I would pick A. Any questions? Okay, I believe it means no. Move on to the second one. What is true about the function f of x equals 1 over 3x plus 5 as x approaches negative 5 over 3 from right-hand side? Remember, this plus indicates that we approach this value of x from the right-hand side. If it would be minus here, it means from the left. So this function, let's see what happens when we substitute negative 5 over 3 in here. We're going to have 1 over 3 times negative 5 over 3 plus 5. After simplification, we're going to see that it's in the denominator. It's going to be negative 5 plus 5, which would give us 0. And we remember that basically it means we have asymptote, vertical asymptote for this rational function at x equals negative 5 over 3. And we're supposed to identify what happens when we approach this vertical asymptote from right-hand side. If you imagine the graph, so we're going to have this function and negative 5 over 3 is going to be a vertical asymptote. And it means that on one side of this vertical asymptote, graph goes to the negative infinity, and on the other one to the positive infinity, right? So what would happen if we take negative 5 over 3 to the right, so from this side of the function? So it's going to be slightly less negative number than negative 5 over 3. So as a result, denominator, so it won't be negative 5, it would be negative 4.99 something plus 5 would give us positive number, very small but positive number, right? Which means if we divide 1 by this very small positive number, we're gonna get positive infinity. So my choice would be B in this case. Any questions about this? I'll wait. Okay, guys, as I see no questions coming, so let's move on to question number 3. What is true about the function f of x equals -1 over x negative 3 as x approaches negative infinity? So basically, we're asked to see the end behavior of this function. Let's see what happens if we substitute x for x some huge number. For an instance, we're going to have 1 over, let's say, 1000 minus 3. What we're going to see here is that it's 1 divided by 997, which is fairly big number, and result is going to be close to 0, right? But with minus, the result is going to be close to 0 from negative side, or in other words, from below, right? This is our x-axis, this is our y-axis, and here is 0 for this, where we approach 0 from negative side on y-axis, and this is where we approach 0 from a positive side on y-axis. In this particular case, options we have f of x travels to 0 from above. Doesn't work for us because we approach from negative side. Then C, f of x approaches 1 over 3. We didn't see that, so it doesn't work for us as well. Undefined, no. But from below, B would be the right answer. Is that clear? Please give me your feedback. Okay, so I suggest we move on because these are only multiple choice questions. Then what is the x-intercept of the reciprocal function f of x equals 3x minus 4? So we have to have the reciprocal function for this one. It would be 1 over 3x minus 4. And what is the x-intercept? So what is the x-intercept? So x-intercept is when y equals 0. But the question is it possible to get y equals 0 for this function? There is no way to make it equal to 0 because our numerator has no variable in it, and it has only constant value of 1, and denominator, no matter what denominator you make, it would never make the equation equal to 0. So my answer would be there is no x-intercept for this function. Okay? What is the equation of the horizontal asymptote of the four-ring reciprocal function of a linear function? What is the equation of the horizontal asymptote? Does anybody remembers how to identify horizontal asymptote? So basically, horizontal asymptote is the value of x. Oh, sorry, is the value, yeah, is the value of y that could never be covered. In this particular case, it's pretty similar to what we did just before. Basically, horizontal asymptote could be also treated as the exclusion from the range of this function. As you can see, 1 over 2x plus 10, with minus in front of it, could never be equal to 0. Thus, our horizontal asymptote would be y equals 0. We could infinitely approach this horizontal asymptote, but we would never touch it. Y equals 0 would be our horizontal asymptote here. So answer would be A. Okay? Question 6. Which function has a domain consisting of real numbers? That's an interesting question. So domain includes all the x values, right? X, E, R, real numbers. So what, um, let's recall what real number means. So just so you remember, any whole number, integer, or in fraction, considered a real number. Complex numbers are excluded, and negative numbers are included. Any suggestions? Okay, here the answer would be D, and I'll explain you why. Because in first example, there's going to be an exclusion when x equals 25, because it would have a vertical asymptote. As well as this one would have a vertical asymptote at 25, so not real, it consists of real numbers, but partially. We have exclusions. For this one, there is a square root of 25, which gives us 0 in denominator. But the final one, D, it has x squared plus 25. What you're supposed to see here, that no matter what number you take instead of x in here, denominator is always going to be positive, because any number squared is positive. We add positive number to it, so result would be always positive. Thus, there is no way for us to get 0 in denominator here. So answer D. Is that clear? Any questions, guys? This is really important. Okay, guys, I believe no questions here. Question 7. Which function is always positive? In this one, you can see that you have more choices, but I believe they're kinda misaligned. Okay, wherever. Let's see which function is always positive. This is fairly simple task. In this one, you can see that you can make denominator negative fairly easily. In this one, C would be always positive because there is no way for us to make denominator negative and numerator is positive itself. Then moving down, what we see here, 1 over x minus 4 squared. Also good example of function that could never be negative. Because as you can see, in denominator is squared, which implies that it's going to be positive. The numerator is 1, which implies that it's going to be positive as well. While this example doesn't really match us, because yeah, there are plenty of ways of making it negative. For example, make denominator negative, numerator positive, or the other way around. So I would stick to two answers, this one and this one. So B and C. B and C. I don't know why it has two B's. In your final test, it won't be this way. Okay, moving on to question 8. What is the value of k in the function f of x equals to x plus k over x plus 3 if it has a y-intercept of -3? So basically y-intercept, it means x equals 0, y equals -3, isn't it? Y-intercept. So we basically have to substitute these numbers into the function to see what k value are we going to. So -3 equals 2 times 0 plus k over 0 plus 3, which gives us k over 3. Or in other words, k over 3 equals -3. Now we multiply left and right hand side by 3 in order to isolate k. And we get k equals -9. And luckily, we have this choice here. Good? Can I move on? Okay, great. Number 9, which of the following functions has a whole at x equals 5? And let's recall, how do we identify the whole? Does anybody remembers that? Okay, so what we have to do is to look for the factors, for the common factors in our rational functions. In this particular example, it says that the whole appears at x equals 5. And what we can tell about these functions, that, for example, here we have the solution is not defined for x equals -5, because then denominator equals to 0. But it's not, so this one doesn't suit us. This one actually has discontinuity at x equals 5, because denominator equals 0, as well as the numerator equals 0. And we also have to check if x minus 5 would be a common factor for them. And it's easy to check because we know the difference of a squares formula. So it's going to be x minus 5 and x plus 5 divided by x minus 5. These two terms will be cancelled, and x plus 5 would be left behind. But we shouldn't forget that we had x minus 5 in the initial equation, which means x does not equals 5 for us. As well as for example C, you can see the same dependency. You're gonna expand the difference of squares, and you're gonna see that x plus 5 and x minus 5 will cross out, equals 1 over x plus 5. And again, we shouldn't forget that initially we had x squared minus 25, and x equals 5 would give us 0 in denominator. Thus, x does not equals 5 here either, which tells us that these two functions, b and c, are going to have a whole at x equals 5. So the answer would be D, B and C. Okay, guys, let's move on to question 10. And then I'll ask you to do question 11 on your own, and we're going to have a 15 minutes break, okay? Analyze the following key features of the given equation and then graph it. So 2x squared plus x minus 6 over x squared minus x minus 6. Moving on, question A, x and y intercepts. X and y intercepts are fairly easy to find. First, we substitute x equals 0. This is the easiest part, I would say. This is how we find the y-intercept. If we substitute x equals 0, we're going to get negative 6 divided by negative 6. Because this term, this, and that are going to get crossed out. Negative 6 over negative 6, as a result, would give us 1. Okay, so this is talking about y-intercepts. Let's leave a point on the graph here, y equals 1. Then how to find the x-intercepts? Basically, we need to set y equals to 0, and the way it's possible is when the numerator equals to 0. So 2x squared plus x minus 6 equals to 0. And now we just have to solve this. I love to use discriminant. So b squared minus 4ac equals 1 plus 8 times 6. 8 times 6 gives me 48, which results in 49. Thus, the square root of discriminant would be equal to 7. If I'm not wrong. Yep. Then x1 and x2 equals to minus b plus minus square root of discriminant divided by 2a, which equals to negative 1 plus minus 7 divided by 2a divided by 4. So negative 1 plus 7 would give us 6 divided by 4, 6 over 4. And negative 1 minus 7 would give us negative 8. Negative 8 divided by 4 would give us negative 2. So these are potentially two of my x-intercepts. But I have to check if these solutions are suitable for the numerator. Because if the numerator turns 0 with one of these, then we have a discontinuity in the point. So let's check. If I substitute negative 2 in here, it would be 4 minus 2 minus 6, which gives me 6 minus 6 equals 0. This is what I've been talking about. Negative 2 is out of the domain of this function, so I can't use it. What about 6 over 4? I believe 6 over 4 should be okay. It'd be 36 over 16 minus 6 over 4 minus 6. I believe it's obvious that this expression does not equals to 0, so it's okay. So now I can tell that I have only one x-intercept, which is x equals to 6/4. Meanwhile, y-intercept is 1. So 6/4, it's like 1 2/4 or 1.5. So it would be somewhere here. This is my y-intercept. Talking about horizontal and vertical asymptote. So basically, one of my vertical asymptotes is going to be x equals -2, I believe. Or is it going to be a discontinuity? Guys, please join me in discussion. What would you do here? So vertical asymptote would be present when denominator, the one on the bottom, equals to 0. We already know that -2 would be that one vertical asymptote. But as soon as it's quadratic function here, we may have another one. So let's check. X squared minus, well, let me see, it's B, C, D also here. So what I want to do is, I'm going to keep writing here until I can't. I'll clean this. We don't need this anymore. We only need those 2 points, x and y-intercept. So x minus 6, let's set it equals to 0. Using discriminant, it would be b squared minus 4ac equals 1 plus 4 times 6 times 24, which gives us 25. Square root of discriminant will give us 5, right? So x1 and x2 equals to minus b plus minus square root of discriminant divided by 2a. In our case, it's minus b is 1 plus minus 5 divided by 2. 1 plus 5 would give us 6 divided by 2, which is 3. And 1 minus 5 would give us -4, which is -2 as a result of division. And exactly as we discarded before, -2, one of the vertical asymptotes, as well as 3 is going to be vertical asymptote as well. So -2 and 3. Okay. These are two of our vertical asymptotes. What about the horizontal asymptotes? Any ideas? So we're going to remind you one of the cool properties that we learned. First of all, when we're looking into horizontal asymptotes, we have to look into the exponent in our expression, right? Here, numerator and denominator both have the greatest exponent 2, which means we have to use the following property, that when those exponents are equal, n equals m, this is n, this is m, horizontal asymptote will appear at y equals a over b. A is the coefficient in the numerator, leading coefficient, and b is the coefficient in denominator. In our case, we can see that it's going to be 2 over 1. So basically 2. So we're going to have a horizontal asymptote at y equals 2. Remember that if n less than m, then horizontal asymptote would be y equals 0, or the x-axis. If n greater than m, then no horizontal asymptotes at all. Okay? Let's see what's next. Behavior near vertical asymptote. Behavior near vertical asymptote can be identified by approaching x to -2 from positive and negative side, because this is one of the vertical asymptotes we have, and approaching x to 2.5 from left and right hand side, from right and left hand side respectively, plus from right, minus from left, and see what happens if you substitute those values into the formula. Let's work with -2. When you substitute -2 into numerator, what is going to happen? Okay, guys, I feel like you're not really with me right now, so I'm gonna give you a 10 minutes break, and then we'll continue from the same spot. And I want you to examine what would be the behavior of the function around vertical asymptotes. I did the most of it. Now you just need to substitute these values and calculate them. Here, one vertical asymptote, -2, and the second vertical asymptote, 2.5. Okay, 10 minutes break, and then we continue. Okay, guys, are you ready to continue? Did you found the behavior of the function around -2 and -1/2? Guys, are you with me? Anybody? Okay, Hala, did you found the behavior of the function around -2 and around negative oh wait, no, not 1/2, sorry, but around 3, right? This is our second vertical asymptote, 3. So you can do that on your own, but I'll tell you that to the right hand side. I suggest to the right hand side from -2, it's supposed to be negative infinity. To the right hand side, the left hand side is supposed to be positive infinity. And for 3, from the left hand side, it's going to be negative infinity. And from right hand side, it would be positive infinity. You can do these calculations on your own so we don't waste time and check this result. Moving on to end behavior and domain and range of this function. How do we evaluate the end behavior? We substitute x for incredibly big positive number, like positive infinity, and negative number, like negative infinity, and see how function behaves in that way. So if I substitute positive infinity into this function, numerator is going to be incredibly big positive number, and denominator would be incredibly big positive number as well. But what we're going to see is that x squared gonna get simplified, and we're gonna have 2. So the end behavior at the positive infinity function would approach to 2 from top side. So we see our horizontal asymptote 2, and that also would be our end behavior around positive infinity. Whether its approaches from plus or minus, how do we see that? Is so what we're gonna see is that it approaches 2 for sure. And yeah, we don't have minus in front of it. Thus, it's supposed to approach from the top side like this, I think. On negative infinity side, again, because greatest exponent is x squared, it means that the negative infinity would eventually give us incredibly big positive number. Same stuff as with positive infinity. And we're going to see that the end behavior also approaches 2. So also will approach vertical and horizontal asymptote like is so. And last questions, range and domain. Range for this function is as follows, is that y, e, r are all rational numbers, but y does not equals to 2, our horizontal asymptote. And domain x, e, r rational numbers, thus x does not equals -2 and 3 because those are our vertical asymptotes. These are a range and domain for this function. And then by completing all of these steps, we should be able to plot this function fairly easily. Can I clear the desk now and move to the next question? In order to, so I suggest, I suppose graph would look something like this. Parabola on the bottom and two branches like this and that here. This would be our graph. Move on to question 11. You can do this as practicing on your own because it's fairly similar to what we just did. And you just need to find the reciprocal of it and sketch it. Let's see what else do we have here. Let's see this practical question where we have some real life situation. So the research and motion company estimates that the revenue and cost functions for a BlackBerry are given by revenue of x equals -x plus 10 and cost of x equals 4x plus 5 over x, where x is the number of phones produced in thousands. So 1x equals 1 equals 1,000 phones produced. And the output is measured in dollars. So y gives us number of dollars. Determine the number of phones produced for which the company is making a profit. So basically, company would make profit when r of x is greater than c of x, when revenue is greater than the cost of production, right? So we see right away that 0 is not suitable result for us, so there could be no 0 phones produced. So what I'm gonna do, I'm gonna write this inequality using the equation. Yes, I will post this file to Google Classroom. So -x plus 10 supposed to be greater than cost. So it must be greater than 4x plus 5 over x. Now we have to solve this inequality. The way we can do it is, first of all, let's move all of them to the one side of the inequality sign. So -x plus 10 minus 4x plus 5 divided by x greater than 0. Greater than 0. What can we do here is I would get rid of the denominator. I would multiply left and right hand side by x, so I would get -x squared. Now, let's multiply it by -x in order to get rid of the minus. So multiplying by -x would also change the inequality sign to the opposite one. We're gonna have x squared minus 10x plus 4x plus 5 less than 0, because we multiplied by a negative number. Now, considering this, we just need to solve this quadratic function for 0 in order to find roots. So what I see is x squared minus 6x plus 5 less than 0. X squared minus 6x plus 5 less than 0. Now, let's use discriminant to solve it. Discriminant equals b squared minus 4ac equals 36 minus 20 equals 16. So square root of discriminant equals 4. x1 and x2 equal to negative b plus minus square root of discriminant divided by 2a. Negative b is 6 plus minus 4 divided by 2, because a equals 1, which gives us first 10 divided by 2, 5, and second one, 2 divided by 2, 1. So we have two roots, 1 and 5. Basically what it means is that we have three intervals, number 1 before 1, number 2 from 1 to 5, and number 3, 5 and more. What we have to do here is to check how functions behaves on each one of these intervals. Remember that for us, function is limited with positive values of x, because we cannot produce negative amount of phones. So our domain is as follows: x, e, r, and x greater than 0 and cannot be equal to 0. So in first interval, I would take 1 over 2 and substitute it into the function to see what result it gives to us. Keep in mind, we need to get negative result. 1 over 2, if I substitute 1 over 2, I would get 1 over 4 minus 3 plus 5. And as for me, this is positive number. This is positive number. This is greater than 0, so here it would be positive. Now, from 1 to 5, I would pick 3 for an instance. So substituting 3 would give me 9 minus 6 times 3 is 18 plus 5. It's obvious that this is less than 0, or actually it equals to 4, negative 4, which is the result that we want to see. So it's negative here, and greater than 5. Let's substitute 6 in there and see what happens. Substituting 6 would give us 36 minus 36 plus 5, which is greater than 0. 36 minus 36, we'll left behind with plus 5, and on the third interval, function would be positive, which brings us to a conclusion that number of phones produced for each company is making profit should lay between 1 to 5,000 phones, right? Remember, X represents the number of phones in thousands. So my answer for this question would be from 1 to 5,000 phones would be the optimal number of production in order for company to make profit. Is there any questions about this problem? Okay, if no questions, let's move on. The height above the water of a life jacket dropped from 4 meters boat is given by the function. So we're throwing a life jacket from a boat from 4 meters height, where where t is time in seconds after it is dropped, and h is the height in meters above the water. Question A: when does the life jacket reach a height of 1 meter above the water? So basically, we're asked when h of t equals 1. So we have to solve it for 1. 1 equals negative 2t plus 4 divided by t squared plus 1. When does the life jacket reach a height of 1 meter above the water? Easiest way to solve it is like normal quadratic function. We should set one side equal to 0 first. What I would do is to multiply left and right hand side by t squared plus 1 in order to get rid of the irrationality. So I would have t squared plus 1 equals negative 2t plus 4. Now move all of the terms to one side. T squared plus 1 plus 2t minus 4 equals 0. Keep in mind, t could take any positive value, and it would only take positive values because we're talking about time here. And we also see that denominator gives no discontinuities for whatever value of t we pick. So what I'm going to do, I'm just going to solve this quadratic function. T squared plus 2t minus 3 equals 0. Just wrote it in a standard form. Again, using my favorite discriminant, b squared minus 4ac equals 4. B squared minus 4ac equals 4, because b equals to 4 plus 4ac plus 12. So it's 16. Square root of discriminant equals 4, x1 and x2. So basically not x, but t in this case, right? Because our variable is time. T1 and T2 equals negative b plus minus square root of discriminant divided by 2a, which equals to negative 2 plus minus 4 divided by 2. If we add, we're going to get minus 2 plus 4 is 2 divided by 2, 1. If we subtract, we get negative 2 minus 4 is negative 6 divided by 2 is negative 3. But keep in mind that negative 3 is out of the domain for us, so we cannot use it. So my answer would be t equals 1 for A. When does the life jacket reach a height of 1 meter above water? It reaches that height in 1 second after it's dropped. Any questions on how I did this? Okay. So second question. For how long is the jacket going to be above the water? How we evaluate it? We say basically it won't be above the water anymore once h of t equals 0, right? Once it equals 0, it means life jacket touched the water and it's no longer above it. So 0 equals negative 2t plus 4 over t squared plus 1. take into account that only numerator can make this equation equals to 0. So I say negative 2t plus 4 equals 0. This is linear function that is easy to solve. And negative 2t equals negative 4. Thus t equals 2. The answer is so answer would be that life jacket is going to be above the water for 2 seconds. Okay? Moving on. Question C. What do you expect the height to be equal to as t travels to positive infinity? So where would be the jacket after infinite amount of time? If we look into this function, we can see if we substitute t equals to positive infinity, basically, denominator has a greater exponent for t than the numerator, which means denominator greatly defines which result are we going to get while approaching the end behavior. We also see that numerator is negative. It has negative leading coefficient, which is also important. So once we substitute t equals infinity in here, basically numerator, we're going to get negative infinity. And in denominator, we're going to get infinity squared. So infinity squared is much bigger than regular infinity, it's obvious. So I could tell that eventually it approaches to 0. And not just 0, but 0 from negative side. So my conclusion would be from negative side because we have minus in numerator. Which means that for how long is the jacket going to be above, no, what do you expect the height to be equal to as t travels to infinity? And my suggestion would be that if this is our imaginative water level, then the life jacket would be right beneath the surface, right? It would be right beneath the surface from negative side, from the bottom side. So it won't float, basically, according to this function. It will float, but under the surface of water. Okay? And now, moving on to next question. Write an it's the last question, actually. Write an equation to represent a rational function with the following conditions. Reciprocal of a quadratic function, asymptotes with equations, and the following behavior for y less than 0, for x less than -5. Yeah, I can help you with the first stage. Reciprocal of a quadratic function. So basically it implies that your initial function should be quadratic, like ax squared plus bx plus c, and its reciprocal would be 1 divided by ax squared plus bx plus c. This is the first stage. Then asymptotes. You should have horizontal asymptote y equals 0, as well as vertical asymptotes. Remember that y equals 0 is an asymptote when exponent in numerator less than exponent in denominator. Asymptotes, horizontal or vertical asymptotes appear when denominator equals 0. So basically these two supposed to be roots of your quadratic equation. So x1 equals -5 and x2 are 4/3. I want you to write your own answer for this question because it could be several answers, several right answers. You have 17 more minutes by the end at the end of this class, and I want you to start now. And if you have any questions, I'm here to support you, okay? Please go ahead and try your skills because test is coming and I want you to do your work as well. Hala k can equal to 1. Which k? Which k value? I don't see k value here. Coefficient, you mean on top, this one? Yeah, it could be. I think yes. But you have to comply with the third properties too. So let's see, if k equals 1, yeah, 1 would work, because if we have coefficient equals to 1, it means that we definitely have an asymptote at y equals 0, because for this n should be less than m is on the bottom, and here we can see that basically n equals to 0, so it works. For third one, y less than 0, for x negative 5, and x greater than 4 over 3. I don't think that k factor really matters here, because this is mostly defined by first of all the zeros of this function, and secondly the leading coefficient, right? It should be negative. So basically I think function should look like this, upside down. So so the numerator should be positive, and it doesn't matter whether it's 1, 2, 3, or any other constant value. Okay, guys, the class came to an end. You have another class starting now, and thank you for participating. Thank you, Hala, for your work. Great job today. And tomorrow we're gonna have the class, I believe the same time, but I'm gonna double check and send it to you on WhatsApp and email as well. Thank you for participating, and I wish you all the best. See you tomorrow.